Hey, good afternoon. Can everyone hear me in back? Good? Great. Good afternoon. I'm Tim Laverty. I'm a program manager on the developer platform team in Windows Phone here at Microsoft. I want to spend the next hour or so talking with you about networking, or the networking support that Windows Phone 8 offers. Really what I want to talk about is connected applications and how you build them. When I say connected applications, what I mean are apps like that drive this Sphero, or that, if you were at the keynote yesterday, drive this quadcopter, or the next car that I have. I have a Lego Mindstorm robot here as well. In addition to those phone to device control scenarios, I want to talk to you about how you build apps that communicate between people. So there's a number of built-in features to the Phone OS that allow sharing photos or videos or so on. I want to talk about those kind of apps as well. And then I want to talk to you about apps where you're talking with services, so Facebook or Twitter, so mostly HTTP access as well. I see, when you look at the apps in the marketplace, a really solid set of those, or solid percentages of those, I would say, of the best apps, the highest rated apps, are connected apps. So this is, I think this is a critical subject area for you as you're building applications, because these connected apps are really what, in large part, oftentimes make apps great. So from there, I'm going to walk through today, and I'll talk about how we build these kind of apps and what the Windows Phone 8 API surface is that lets you build the apps. And my focus will mainly be, there'll be quite a bit of code. I want to spend at least 3/4 of our time inside of Visual Studio showing you how to do the real thing. This is a super broad subject area, so in some cases we won't go really, really deep, but I'd like to bootstrap you with each of these technology areas of sockets, of the proximity namespace, so looking at both Bluetooth and NFC, and then also HTTP as well. And I should say, as I go, I'll talk about the differences and similarities across Windows Phone 8 and Windows 8. And then I'll start out here a little bit with what we did in Mango and how that's changing in Windows Phone 8. It's pretty drastic. So a couple more slides, and then we'll hop into code. So in Mango, we offered I would say a pretty solid foothold in the networking space. We offered a pretty decent sockets API. You had TCP and UDP access. There was one major thing missing from sockets, in that you couldn't listen on a socket. So if you wanted to talk from phone to phone directly over a socket, you needed an intermediary or you needed to multicast, one of the two. From an HTTP perspective, also pretty solid. It was a good story. Actually, probably I would say better, really, from a sockets perspective. We offer the web client API, which offers async access but wasn't awaitable. So if you're comfortable and familiar with using the await keyword, you couldn't do it with web client. We also offer the web request API, which I've seen a number of folks wrap with or making it awaitable for HTTP as well. So, but I would say from a sockets perspective, a good start, a good foothold into writing connected apps. From an HTTP perspective, largely probably everything was there. So Windows Phone 8 really drastically expands on the API surface and capabilities and scenarios that are offered in networking. So we have added access to the Windows networking namespace, which gives you access to the same WinRT socket API that you use on Windows 8. So if you're writing socket code for Windows Phone 8 using the Stream Socket and Datagram Socket API or classes, that same code is going to compile and run in your Windows 8 store apps. And this will segue a little bit later into when we talk about the socket APIs offered. I'll talk about what each of them offer and what I would recommend that you use. We also offer the proximity API. So here you have access to both NFC and Bluetooth. And I'll show a fair bit of code later about how you can connect device to phone to phone and then phone to device. Both of these are work in conjunction with or layered on top of sockets. And then last, I think as most of you know at this point, we've added native code access to the platform. And I'll talk a little bit about the API surface available to native code. Obviously, everything in Windows networking because it's a WinRT API, is available to native as well. So it's a little off, and I don't have native pointing up to the WinRT sockets API and proximity namespace, but you do have access from native code to those APIs. You also have access to IXHWR, so you have access to HTTP from native in a very similar in terms of capability surface that you have in managed, actually. Last, by your demand, by customer demand, we added or brought in the WinSock API to the Windows Phone SDK. This was, we received a ton of feedback from you guys saying, hey, I have existing networking assets that I've built using BSD sockets or WinSock, and I want to use them on your phone. I don't want to rewrite them using either a managed API or the WinRT sockets API. So we've pulled it in. And I'll briefly show WinSock a little bit later. I'm not going to go into a ton of detail there, but the thing to note is WinSock is the WinSock that if you are a WinSock programmer that you know and love. We haven't changed semantics. We've brought in the headers, we've brought in the lib, and you're writing the same WinSock code that you've always written. So with that, let's talk about sockets. We'll go sockets, then we'll go proximity, and then we'll wrap up with HTTP, and I'll show some NFC in context of NFC. 3 different socket APIs offered in the Windows Phone 8 SDK. As I said on the previous slide, you have WinRT sockets, you have managed sockets, you have WinSock. They offer largely the same capabilities. You can listen on a socket, you have TCP access, you have UDP access, you can multicast. As I said earlier, it's the WinSock that you have always programmed against. I wanted to ask, can I get a show of hands? How many people are using the WinSock API in the apps that they write today? Okay, so small number, probably like 2 or 3. How many are using managed sockets, so the Mango API? Okay, good. About half the room. And how many of you have looked at WinRT sockets or are writing Windows 8 apps? Okay, so a little less than managed sockets, but pretty close. Okay, so when I looked at the API surface and I was thinking about were I in your shoes sitting in here, what do I want to know? What I really wanted was I wanted a sample that showed, or first I wanted the capability discussion of what I could do and what I couldn't do across them. And then I wanted to see the code for each. So I wanted to see the WinRT sockets code, I wanted to see the managed code, and I want to see WinSock code. So I'm going to hop into VS at this point. So what I did is I've written a sample app that is a simple client and is a simple listener. And all the client does is you give it an IP address, it opens up a socket to wherever that listener is listening, and then it drops it. It doesn't even send any data. It's bootstrapped to send data, and I'll show you where. And a little later in the talk, I'll show you how you send data over sockets if you're not familiar with it. But in this case, I wanted to show the code for, or have, give you guys the knowledge of, okay, what do the 3 different APIs look like? Where's the complexity here? So the listener does essentially the analog of that. So the listener boots up, gets the local IP of the phone, binds to a socket, listens on it, accepts connections. When it gets a connection, it doesn't do anything with it. It just accepts it and then destroys it. That's all. So again, no sending data back and forth. So I'll show a quick demo of the app so you can see it running. Can everyone see that? All right. So this is the server app. All it's going to do is listen on this IP, and it's going to give me feedback for connections that it receives over the socket. So in this case, I'm going to tell it to listen using WinSock. It's listening on 10.69.241.95, so IPv4 address. Yeah, how do I? I'm not sure how to do it. Let me look. Is that better? It's still a little blurry, isn't it? It was better before.
Well, it's not refocusing now. Before it was just refocusing over and over again.
All right. Is that better?
Yeah.
All right. So this is my server, my red phone here, the pretty one. He's listening over WinSock on this IPv4 address. Here's my client. I knew what the IP address was, so I pulled it into the text box already. Otherwise, I would have to type it, which kind of will segue us into talking about the value of, say, something like NFC or Bluetooth, the fact that I have to know what my endpoint is. So I've typed in my IP address here. If I want to send with managed sockets to that IP address, it hopefully will make a connection. This assumes that they're both connected to the network. Which they're probably not. Okay. This is classic demo time. Sorry. Okay, I can walk through the code in a minute. Essentially what should be happening here is that my server is listening on a predefined port. My client is making that connection and then dropping it. Yeah, obviously failed to connect. I'm going to try one more time to connect through wireless. Well, actually. Okay, apparently I've lost my wireless connectivity. All right, I'm going to hop back to the code, and I'll show you what the code looks like for each of these. At least I've lost my wireless connectivity on my client. Okay. All right. So if I looked at the managed API code, so this is my listener. Really what I want to walk you through is the client. So I'll pop over the client. Looking at the managed API that you see here, I have a class that's wrapping up all of my managed communication. And it already defines a static port that it's listening on. It grabs a new socket, resolves that IP address, and then makes a connection, setting up it previous to that, it's connected complete. So it's running asynchronously, saying, hey, make the socket connection for me, and then call me back on this completed method. So once it's finished, what you would regularly do is you would handle the connection and then start sending your data through this handle send method. So writing the code for managed sockets, somewhere around 100 lines of code. So I think if you removed my comments and some of the send code stub that I have in here, it'd probably sit somewhere right around 85 or 90. If you looked at, say, the WinSock code, then for the WinSock guys in the crowd, this is exactly the same code that you would write on the desktop. What I did is ported a desktop app that I wrote in the mid to late 90s to the phone when I wrote this. So it's the same code. You're calling WSA startup. You are resolving the host that you're going to connect to, then looping your adapters and trying to send over each adapter. So creating a socket and then trying to connect over each adapter. So here again, and then regularly once you got a socket out of it is where you would send and receive data here. At the end of course, you're closing your socket and then freeing up the host character array. So similar to manage, you're talking about 85 lines of code or so. So almost the same amount of code. Probably the managed API is a little bit easier to wrap your head around, maybe a little bit easier to maintain. Previously, I probably would have tried to push you towards using managed if you were writing this kind of code and you were writing a Windows Phone app. So in this case, I have not implemented the WinRT socket API, and I wanted to, this really showcases how easy it is to use the WinRT socket API. So again, hard-coded to port 4533. If I get rid of any syntax errors I have. Sorry, what's that? Thank you. All right, a couple lines of code. So we go from writing managed code, where we're talking around 80 for very similar connectivity code to this. WinSock around the same, 80 to 100, to the WinRT API, where it shows it's really, really lean. And this kind of ties back to when you talk about, well, what should I use? And looking across the different socket APIs, the advantage of using WinRT sockets, we would definitely recommend you use these. Use the stream socket class, use the datagram socket class. These are really lean code. It's a very well-designed, succinct API. And it'll run in your Windows 8 store apps as well as in your Windows Phone apps. If you have existing assets that are built using the managed socket API or the WinSock API, or you're looking at OSS libraries that are built on top of BSD sockets or WinSock that you want to bring into the phone, that's great. I would highly recommend reusing those. Like, there's no critical reason that you would need to come to WinRT sockets. But if you're writing something new, you're building a new app, that's what I would recommend. Okay, I'm going to move a little bit to proximity. So I'll give a brief intro to Bluetooth and then a brief intro to NFC. We'll do some Bluetooth demos and then look at NFC in just a few minutes. So the transmitter class of the Bluetooth inside of the phone is not specified in our hardware spec. So you'll see variants in the phone devices that you have or that you purchase. The range will be somewhere between 0 and 100 meters. With the phones that I have that you saw on the Wolf Vision, I see, like, I have played a fair bit with the devices that I have here on the floor, the Sphero, the robot, and the helicopter. I see somewhere around 80 meters of range with the robot specifically. So pretty good transmitter in these devices, pretty good range. Probably not super critical unless you're dealing with something like the helicopter that's going to fly away from you, right? Yeah. So, yeah. I've seen great YouTube videos of folks' helicopters flying above their houses and flying into the forest. Pretty sweet. So Bluetooth resolves down, or Bluetooth, when you make a Bluetooth connection, it uses a WinRT stream socket that's running over RF comm. You get about 2.1 megabits per second. I have a demo a little bit later that I'll show that's using this, and it's really more like around 800 megabits per second is what I'm seeing here. Both of these allow app-to-app or phone-to-phone connectivity and app-to-device connectivity as well. With NFC, probably the primary scenario that I would talk about will be these stickers up here that I have. And I'll show how you can write tags using NFC and then read data off of those tags and leverage it. NFC, different from Bluetooth in that you're talking about a physical or explicit connection. With Bluetooth, I talk to these devices. They don't have to be near each other. With NFC, I'm basically putting them together, and you can hear the audio cue if I'm quiet, or if I put it up here maybe. So that's basically saying, hey, our NFC radios are talking to each other, essentially is what it's telling me. And I'll talk about the API surface for NFC and what the state machine looks like for how you actually make that connection and pull a socket off of NFC. So you can exchange a little bit of data, but also a great thing about NFC is it will also give you a stream socket and let you run over run over Bluetooth socket, essentially, over RF COM for stream socket. Excuse me. So NFC is really built around acquiring a connection and exchanging small amounts of data, and then, if you want, bootstrapping WinRT stream sockets. So, and again, both of them app-to-app and app-to-device scenarios. So with this, I'd like to show a small Bluetooth demo and talk through what the Peer Finder proximity API looks like to actually establish a Bluetooth connection. And what I'm going to do is I'm going to control this robot. I hope. Considering how my last demo went, we'll see. So my UI here will not receive any accolades, but basically what it does is when I hit start, it's going to create a socket to that robot and then start driving it. Yeah. You can see what it's doing is the phone has a stream socket to this robot. The phone is hooked into sensors so that every time the phone takes a sensors reading, it's pushing a left wheel command, right wheel command, and then go to it. The robot is actually a super cool robot. It's built or it's based off of the Lego Mindstorm kit. A friend of mine, Roger Chang, actually built the robot for me. And I'll walk you through the code that you actually write to connect to it and get the socket. One thing with these devices is the socket protocol, or how you talk to a device, it's dependent on the device. Each of these devices, the Sphero, the Nextcar, the helicopter, or the quadcopter, they have their own protocol. So the key thing for us is how do I open a socket? Now, how do I start talking to it? And then you're going to the vendor, the person that writes the firmware for this device, in this case, the Mindstorm, and asking them, hey, what's your protocol? Like, I have a socket to you. What do I send to you to make you do things? Is essentially what you're asking, okay? One great thing about the Mindstorm kit is that the socket protocol is published. It's, it's open. It's on the web, so you can hop up there and pull it off. So it's a really fun toy to play with and experiment with when you're working with sockets. So let me show some code. Okay. So as you saw in the GUI, you have basically a start and a stop button. All the start button is going to do is open that socket and then start pushing data over it using the accelerometer. So let's look at what's under start. You have this await setup device connection, which I haven't yet implemented because I wanted to show you how to initialize Bluetooth and how to get a socket. Once you get a socket out of this, then we're going to give it to this car control class. This car control class, the only thing it knows about is you give it a socket, and then it knows what the protocol is between you and the robot. So all it'll do is the car control class, and I'll show it in just a sec, is the car control class has a socket pointer. It takes it inside of the constructor. It pulls or it creates a data writer, which a data writer is the mechanism that you use to push data over the socket. So you create a new data writer using the socket's output stream. Once you have this data writer, you tell this car control class, here's what I want my left speed to be. Here's what I want my right speed to be. And then you tell it to move. And this right wheel update function is really, this is the robot's protocol. So this is what you're actually sending over the socket to make it do things. And again, the protocol that you use it's entirely dependent on the device. Like every device has its own firmware, has its own protocol that you use to push it, or make it do things. So in this case, here I'm setting the left speed and the right speed. I'm setting its run state, and then I'm telling it, hey, when I send you a command, I just want you to keep executing it. That's what I'm telling it here. So before we can actually leverage this car control class, like I was saying before, we need a socket. So how do we know that the Bluetooth device is there, and then how do we pull that Bluetooth device, get its connectivity information, and create the socket? So I'll write that code. So the first thing that you do is you put the PeerFinder API in app-to-device mode. And the way that you do that is using this alternate identities property, okay, or setting this alternate identities property. Next thing that you do is find all peers. And I've written some error checking code here so you don't have to watch me write it. So basically, the only thing I'm doing here is I'm saying, with this PeerFinder find all peers async, I'm saying, hey, give me every Bluetooth device that's paired with my phone. Obviously, I just drove the robot, so I've obviously already paired the robot with my phone. So this find all peers async is going to return me a collection of every Bluetooth device that's already paired. So the next thing I need is this peer information object. And I'll write a simple link query. To actually go grab it. So first of default will return null in this case if it can't find a Bluetooth device that has a display name that contains NXT. And again, in this case, I have a little bit of error checking that I pulled into a snippet. So and if I haven't paired the next car with the device already, then I'll pop up an error message to the user of the app that says, hey, you haven't paired it, please go pair it. Okay. So once I have this peer information object, I have everything I need to create a socket. Okay? What it will bring back is all of the RFCOM or all of the stream socket info that it needs to actually open up and talk to the device. So what I do is I create the stream socket, I call connect async on the socket, and I give it the host name. The other thing that it obviously wants is it needs a port. Most of the devices that I've built apps as I've been testing the phone with, most of them listen on port 1, which for these kind of devices like the Sphero listens on port 1, as does the next car. Most likely the apps, and I haven't looked at the API surface for these in the firmware, you change the port that it listens on, but I haven't looked at it. So in this case, I want to pause for a minute and do a little bit of cleanup so you can look at this. So these are key concepts or key code that you need to write if you were creating an app that is connecting from phone to device. So you're enumerating all of the paired Bluetooth devices here. Or I should say, you're putting the phone or the API, the PeerFinder API, in app-to-device mode. You're enumerating all of the devices. You're finding your specific device, the one that you want, your peer information object. And then you're opening a socket for that device. One thing I should say is I noticed some folks are taking pictures of the code, which is fine. This will be posted with the talk. So all the code that I'm writing, everything that I'm showing to you, it'll be up on the build site with the talk. There's a huge amount of breadth and surface area here, and every once in a while I see somebody that's writing it as I'm talking, and I'm like, no, I'll post it. Don't worry about that. Okay. So I've got a socket. So I also have a car control class that needs a socket in order to communicate with the next car. And all I do with him is I create that new car control class, and then I give him that socket right here. And in this case, that's it. So this is really it. This is, in terms of when you're communicating from phone to device, this is really what you need. Putting that PeerFinder API into phone-to-device mode, enumerating those devices, pulling your device, and then opening a socket up to it. So here, I'll go ahead and run it. And if I hit start, and you see the device running. Okay, so yeah, go ahead.
So does Bluetooth automatically manage things like baud rate, parity, all the other standards?
It does. Our stream socket will wrap that up for you. So the question was, does Bluetooth handle baud rate, parity, etc.? And the answer is yes, our stream socket wraps that up for you. So I should have said, I have sectioned off time at the end of the talk to take questions, and also I'm available after too. I'll be in the booth, or I'll be able to step outside. If I can't answer your questions, then I'll give you a card, and we can chat over mail or over Twitter. Or my Twitter account. It's at the front of the deck. Okay, so after Bluetooth, I want to talk a little bit in more detail about the HTTP support that we offer. And then I have another demo or another sample that walks through using HTTP and also NFC. So the HTTP support is really largely what we offered in Mango. You have the Web Client API, which is a nice wrapper around HTTP. It's asynchronous capable, but doesn't support the await keyword. If you want to use await, then you can wrap HTTP web request, and it'll work great. The Windows 8 API service is slightly different, and this is something that you might want to be cognizant of, is that we don't have HTTP client on Windows Phone 8 like they do on Windows 8. The HTTP client Windows 8 API is awaitable as well. However, both platforms do support HTTP web requests, so both are awaitable. From a native perspective, they're the same. It's IXHWR. So here I'd like to hop into an NFC and HTTP demo that I have. And Sam Jarwin, my colleague, helped write this. Kind of collaborated on it. So the app is pretty straightforward. All you do is you give it a URL. It goes out, it downloads a song off of that URL, writes it to ISOstore, writes it to your music library, and allows you to play it. So I'll run it on the app that has a network connection here. So if I download to my music library, it pulls it down, and then starts to play the song. So, which is great. I might, though, want to share that song with someone. I'm obviously not sharing songs that you don't own, but I might want to share that song with someone by, say, tapping and connecting and streaming that song over to another phone. And this is what the tap and share or tap and send button allows you to do. It uses NFC to create a stream socket between the two phones, and then uses that socket to push the song to the other phone where it's stored in ISO Store in your music library and where you can play it. So I'm going to show the HTTP code real quick, and then I'll hop into how you use NFC to actually communicate to the phones. And then last, I'll talk a little bit about tags and how this whole scenario could be extended by using tags in a few minutes. So. Okay. So when the download button for a song is clicked, it's going to do a fair bit of verification that the URI that you entered in the text box is valid, which is all here. It's setting up some UI so that you get feedback on whether it's downloading successfully. And then really, all of the HTTP code, or the core HTTP code, is what you see highlighted on the screen right now. The only thing I'm doing is I'm creating the web client object, and I'm setting up these two events so that when I start that HTTP download, it gives me progress, and then when it's finished, it gives me a complete, or it fires the completed event as well. And let's look at the events here. So here's the download progress change. Only thing that's happening here is it's incrementing the download progress bar. That's it. And then when it's completed, it's a little bit more interesting in that once it's complete, it's creating this file name. Here I've wrapped up writing that music file to ISO Store. I'm not going to open this up. You're welcome to look at it once the code is posted. But it's writing the song to ISO Store. It's saving it to the media library, and then basically saying, okay, I did it. Like, go ahead and play it. What you just saw demoed on device. Okay, so let's talk a little bit about the tap and send scenario. So here I have a class that is wrapping up all of my NFC communication. There are a number of really cool helpers that are available out there. Our partners at Nokia are building a couple NFC apps that show you how to write tags, read off of tags, and run these app-to-app scenarios. In the resources section at the end of the deck, I have a couple pointers to them. I also had a great conversation with a guy on Twitter yesterday who's building a similar but different set of apps for different scenarios that is also in the resources section of the deck. So in this case, I've wrapped up the NFC code for making a connection from phone to phone. I didn't write it, and I think what I'll do is just go ahead and we'll write it real quick and then talk about what we do once we establish that connection and how we resolve that into a socket so that, again, we can talk. In similar fashion to the last demo, I've created a separate class that once you have the socket, it handles streaming the song across and then writing it. And that's it. So what this is doing is it is saying, hey, I want you, when you get an NFC connection state change, so when you get NFC activity, I want you to fire this event. So I want you to fire this method right here. And that essentially, so basically it's just a hook. Then when you call start, it is starting the PeerFinder state machine. So when I say PeerFinder state machine, what I mean is this event gets called multiple times over the life cycle of your NFC radio making a connection with the other phone. When it gets called, it passes in this triggered connection state parameter. And so basically you're set up where in this event or in this method, you react to it. Here it's saying, hey, I found a peer. There's not much you can do with that other than tell the user, hey, we'll keep them together. Like, keep them together until I can actually really do something and open a socket. Here, when it's completed, you can obviously do a lot with this. If it's completed, excuse me, the E argument will pass in a socket. So this, once it gives you the completed status in the event, you have a socket between the two devices, so you can thereafter start sending data over it. And then down here, I'm also checking the failed and the canceled, so I can tell somebody, hey, like, it didn't work. So let's go ahead and build and deploy it, and then run it. So I previously already downloaded the song to this red phone. If I click tap to send, he starts listening. So the phone, this red phone with the song, is now looking for an NFC connection. That state machine has started, so that event method, the triggered connection state change, is going to fire whenever he gets an NFC connection. This phone, I also hit tap to send. I don't have any songs here, and I'd like to transfer the song from my red phone over to my black phone. When I pull the devices together, it's going to be hard to see, I apologize. It runs through that state machine. Until it actually opens the socket. So what it's done is it's used the NFC PeerFinder API over NFC to make a connection, create a Bluetooth RFCOMM socket between the two devices, and then what you see now is this red phone is streaming that song data across to the black phone, where it thereafter would get pushed to ISO store, put in your media library, and played. I can think of a ton of applications for this type of scenario. I don't know that sharing songs is one of the primary that I would suggest, but this app essentially showcases the core technology that you would need to write this kind of app. So once the song's streamed over, I can play it. And obviously, it had no HTTP connection, so you know it was real. Yeah. OK. So great. I can go to HTTP. I can download this song. How do I know what the URL is? And Sam and I were talking about this, and one of the ideas that we came up with was, I walk around downtown Seattle, and I see posters up on telephone poles all the time of my concert or my song or whatever it is. So my wife last night built out some posters, and what we did is we placed NFC stickers underneath the posters and wrote the URL that pulls the tag off of them. So if I then walked up to this poster and I see this NFC icon here, then I could walk up to that telephone pole and be like, the band sounds interesting. I haven't heard them. I might want to go. I scan the poster. It pulls the URL into my phone. I download the song, and I listen to it right there before I decide whether I want to actually go to the concert or buy tickets. Another scenario, which our Nokia partners let me borrow these, it's super cool, is this is a Michelin Guide NFC-enabled tag. And how they're planning to use it is there's a great Michelin Guide app for Windows Phone. It's unfortunate because it only right now shows reviews and guides for for restaurants in Europe. If you're not familiar with Michelin Guide, it's a great guide. It basically gives you really detailed reviews of restaurants and so on. So what they picture is hey, like this restaurant's been reviewed by Michelin. A lot of people depend on Michelin or want to use it to actually evaluate whether they're going to eat there. So the restaurant puts this up in their window. You're walking by the restaurant. You see that the tag is there. You see that it's NFC enabled. You scan your phone. It opens the Michelin app and actually where you can read the review. So another, I think, really cool application of NFC. So if I go back to my scenario of my flyer, actually, I might get my flyer. So I already wrote this tag. So there are tags underneath here that have HTTP URIs to go download songs. So if I come in here and I scan, this is, for some reason, the poster conflicts with something on the bottom of the Wolfvision, so I'm going to hold it up here. And what it'll do is it'll read the URL actually off it. Let me kill the app. So it reads the URL off of the tag. So you can see it saying, hey, like I have some NFC content. It looks like you scanned something. If you did this accidentally, you would obviously hit ignore. It was purposeful, and I want to hit accept. And what it's doing is it's saying that the content that you scanned off of here is associated with an app on the phone. This is done through a URI scheme, which I'll talk a little bit about in a few minutes. But the scenario is basically I'm walking up to that telephone pole. I'm scanning the poster. I'm hitting accept. It's launching my app and placing that URI here, whereupon I download the song, I play it, and then I decide whether to buy my tickets. So I want to show you how to write the tag. And then from there, we'll segue maybe into the code that's written, how to read the tag. Depends on time, how to read the tag and launch the app off of it. So this is, writing tags is super easy. This is an NFC writer app. I'll pull up the UI so that you can see it. So the NFC writer app, all this does is it takes this URL you see here, it writes it to a tag. The other things that it has in it is it will, as it sees a tag come underneath, it will give you a device detected message and a device departed message. Both the device detected and device departed are really there to help with UI. I mean, they're there to tell you that the tag came in scope or came out of scope. If I then, in this case, the device is detected, if I want to write the tag, I click this Write to NFC Tag button, and I get an NFC tag written off of that. So whatever was on this tag, I just rewrote it with whatever came out of the app. So let me show the... I'll wait to talk that. Okay, so here's the code there. Here's the app that is actually writing the tag. So I'll walk through the code. Like I said, this is relatively straightforward. When the app starts up, it's setting up it's putting it inside of that URI text box, the URI that it's going to write. So it's putting in a default. You could put in whatever you want. Notice this free tunes colon. So what free tunes colon is doing is it's basically saying, hey, I'm a URI scheme. The free tunes app is, in essence, it's associating itself with this URI scheme. So that when you read this tag, the phone knows what app to launch to do something with it. Okay? I don't have to do this. If I had just a regular HTTP URI in here, and I want the phone to open up that URI in a browser, I could, and it would just open the browser. Here we're initializing the proximity device, which is what we're going to use to actually write the tag. Then we're setting up these two events, the device arrived and the device departed event. Again, these are not critical to writing the tag. They're just going to be here for UI feedback to actually say, hey, a device departed when I get the device departed event, and the device arrived in the device arrived event. So here's the key piece. So this is where you're writing the tag. So here you are creating a data writer. You're setting the encoding to UTF-16. You are writing that string to this data writer, detaching a buffer. So detaching an iBuffer from that data writer, and then you're passing this to proximity device publish binary message here. So it's that simple. This last parameter is a pointer, so that once it completes writing the tag, it's going to call me back and say, yeah, I did it. And here you see I'm handling that event and saying, yep, I wrote the tag. Okay. So I think from there we have probably 10 minutes. And I'd like to show the basics of how you associate a URI to a free tunes app, to the free tunes app. So the key pieces here are in your manifest, your manifest basically defines what URIs you're registering to handle. So this extensions element, the protocol element inside it, is saying, hey, I want to handle the FreeTunes URI. If multiple people registered for that URI, they would get a chooser for which app to open it in. Okay? And then the code to actually do something with the data that comes in through NFC for that URI is inside of app.xaml.cs. So here you'll notice that what I've done is created this association URI mapper class. And what this is doing is it's bringing in that URL. It's parsing out the URL, song name, and title, building it, and then forwarding it to the main page. Where if you look at the code behind of the main page for the application, it looks at the URL. It's very similar to passing in command line parameters. It looks at the URL, parses out the name, title, and URL, puts it in the UI for you to go ahead and download. Okay, so I'm hoping that gives you, or that bootstraps you, or it gives you a good idea of how you can use NFC to create a socket between two phones, and then to also write a tag and read off of a tag as well. All right, so some brief review. Windows Phone 8 offers a very complete networking story. You have HTTP access, you have a full set of socket APIs, you have WinSock, and you have the proximity namespace. There are a number of resources that I would recommend taking a look at. If you're spinning up on sockets, then Bij's networking guide is great for learning WinSock. There are a number of pointers to NFC guides from Nokia, and also Andreas Jackel. He's the gentleman that I talked with over Twitter yesterday. And then the other thing I was going to mention is the Michelin guide, the app that actually integrates in with these posters that I was talking about earlier. So I would recommend as you dig in that you take a look at these resources as well. Also here I have some more general, these are about Windows Phone 8, how to get support, how to hook into the forums, how to give us feedback and tell us what we did wrong and what we did right. I would recommend looking at these links. And then of course, also from a community perspective, we use user voice. So we look at what you give us on user voice, we look at what your votes are, and use it to help us guide our planning for our vNext releases. And then last, please figure evaluations out. I'm trying to get better, obviously, and I appreciate any feedback that you've got. So with that, I think we have about 6 minutes for Q&A, and I'm happy to hop out and take questions after. So as you ask questions, please come up to the microphones. That way the camera can hear it and it gets recorded. Yes, sir.
So is RFCOMM the only protocol that developers have access to for Bluetooth on the phone?
Yes.
And even though we don't have access, do we have HID support for devices on the phone for users?
You know, I'm not sure.
Okay.
Yeah, I want to give you a card so I can come back to you. Yep.
Question, Bluetooth serial API, is that not available?
So right after we're done, let me give you the Bluetooth profiles that we offer. For a number of the profiles, if they're built on top of RFCOMM, you could actually extend us and build them yourself. But we do have, I think it's 5 or 6, and I can't remember specifically what they are, Bluetooth profiles that we support. I mean, they're roughly the ones that I guess I think kind of make sense for a phone. They're your audio, your phone connectivity, and so on.
No keyboard?
Pardon?
No keyboard?
No. Yeah. Yep.
Hi. So you showed a, we sort of, as far as I can tell, made up a URI scheme of your own to connect to your app. Mm-hmm. Is there any mechanism that's, what happens if two people happen to pick the same URI scheme for the same app on the same phone?
You would get a chooser to choose which app.
is there any mechanism that Microsoft is doing so people can register saying, here's what I'm using for my app? If you're doing the same thing, that's great, but if you're doing something unrelated, please pick a different name.
I think the other concern that people typically have is someone going to steal or take
Yeah,
my
sure.
URI scheme? I don't know. Let me come back to you.
Okay.
Okay. Yep.
Hi. Was the bug with upload progress changed, fixed from Mango in web client? Because
I'm not familiar with the bug.
it buffers everything, so you don't have an upload progress change. You get, for example, if you upload a 4 megabyte file, since it's buffered at the networking level, you'll get that it's finished after 1 second, even if it's uploading the file.
I hear you. I'm not sure. I'd have to ask. I can definitely find out for you. I know exactly who to ask. Can I give you a card?
Yes.
Okay.
There is also a question on MSDN since November.
Asking the same question?
Yes.
All right, well, send me an email. My email's on this card. Send me an email and I'll go find out. Great.
You mentioned the NFC and Bluetooth. They are slower speed connection. Do you support Wi-Fi?
You can create a socket and run it over Wi-Fi, sure.
I heard Wi-Fi Direct is supported on Windows Phone 8. Is that
So
true?
Wi-Fi Direct is supported on Windows 8, not on Windows Phone 8.
Oh, not Windows Phone 8.
Yeah. So, I mean, in my sample, I'm using, like for the song sample, I'm using NFC to bootstrap a stream socket. In the very first sample that I showed, where I was just basically connecting 2 sockets across phones, I'm using TCP. It's stream socket, so it's Wi-Fi. It's not using Bluetooth at all.
The Windows Phone, you say the Wi-Fi Direct is supported. Is Miracast supported?
Sorry, for Windows Phone, Wi-Fi Direct.
The Windows 8, I mean.
Oh, for Windows 8 it is. Sorry, what was the question?
The Miracast, the
No, I'm not
Wi-Fi
sure.
display.
Yeah, I'm not sure.
Oh,
For Windows 8, you mean?
right.
Yeah, I'm not sure for Windows 8.
Not like that. Wi-Fi Direct. That's a new Wi-Fi Alliance standard.
Yeah, I'm not sure.
Okay.
I know for the phone it's not, but I'm not sure for Windows 8.
Okay.
Yeah.
In the keynote about the helicopter,
Yeah.
you can send the video from the camera to
Yep.
the phone.
Yeah.
How do you do that?
So what happens with the quadcopter is it's a wireless hotspot. So you spin the wireless hotspot up. I can show it to you on Wolf Vision if you want it. I probably should wait till after we're set here.
Right.
So we step out. I'll show it to you. You spin the quadcopter up, and it's a wireless hotspot. You connect to it using your wireless settings over the phone, and then it's open. Like basically, what you're doing is you're sending it UDP packets with direction for the rotors, and then it actually offers a UDP socket where it's sending video to you. I'm capturing frames and then pushing them to a XAML DirectX control, a DirectX control that's embedded in a XAML app. Yeah.
Right.
So we use IMF Media Engine to actually pull the video and render it inside of the app. Yeah. So it's the same as we were looking at here. It's just UDP. It's just sockets.
Okay.
Yep.
On the Windows Phone 8, do you have a strategy to output video to device?
We do not enable. I had another gentleman ask me about that a little bit earlier. I realize this is painful. We do not support DUV out or outputting video from the phones in public builds. We'd love to, and we're looking at it in our vnext. So I don't.
Because
I'm hoping it will be there.
the keynote demo,
Yeah.
there's videos as you can output like
Yeah.
movie to
When
TV screen.
I showed the quadcopter in the keynote yesterday, and I did use DUV out, or I think, it was DUV out for video. So it is something that we've looked at. It's not a, is it technically possible? It's really a question of timing and testing and resources.
But I'm talking about the phone to the device.
Yeah.
So it's the same thing.
Do you mean
Yeah,
pushing?
I'm interested in video output from both directions.
I see.
Yeah,
I mean,
so from
video
phone
from
to
a
the-
device to a phone, you saw yesterday.
Right.
Like I was
How
pulling
about
frames
phone to
off of
the
the
device?
quadcopter. From a phone to, say, a PC,
Yeah, TV or
Yeah,
a
so-
monitor or.
I think you could probably build it because you can pull frames through IMF Media Engine, and you have full access to sockets. So you could probably push the frames. I haven't seen it done. I mean, the DUV viewer, other than that, I haven't seen it done.
Yeah, if it's Wi-Fi direct available, that's good enough. Otherwise, the bandwidth
Great.
is not enough.
Okay.
Can you broadcast with the Bluetooth?
I don't know about Bluetooth. I mean, I can broadcast on a socket or multicast. Yeah. Do you want me to find? I can find out for you. I'm happy to. Yeah. Yeah, you broadcast on the socket.
So how about interoperability with like Android? Is there a story with that? Because I tried on earlier builds of Windows 8.
Yeah, it's a
Wasn't
great
quite
question.
working.